So far, we've spoken a fair amount about what it means for a sequence to converge to a limit value x. But what can we say about sequences that do not converge? A definition of convergence says the limit of the sequence xn when n goes to infinity is x if and only if for every epsilon greater than 0 we can find an integer n epsilon such that distance between xn and x is smaller than epsilon whenever n is greater than n epsilon. That's the definition of convergence for a limit. Well, what does it mean then to say that the limit when n goes to infinity, the sequence xn is not equal to x? We're looking at negating the definition of convergence to a limit x. So what's the negation of this? It is going to be that we can find a specific value of epsilon, let's call it epsilon 0, such that for every value n, which is an integer, with little n greater than n, we must have the distance between xn and x is greater or equal to epsilon 0. And here, when I say with little n, I'm talking about any value here greater than this value. Now, I could have done without actually writing the nn here, but it might just be a good way to remember the choice of this little n depends on what the specific corresponding value of capital N is. Right? I don't know if you've done any formal logic, but this sentence here is the negation of the sentence above. Another theorem for us. 21, by my reckoning, let's say that xn is a bounded sequence. Perhaps sometimes we'll just write this as xn belongs to some ab. If it is the case that every proper convergent subsequence converges to the same x, then the initial sequence actually converges to x as well. So if all the sequences that are proper subsequences of the initial sequence converge to x, the original sequence is itself convergent and it converges to x as well. I need to put the proper in there because, well, the sequence itself is a subsequence of itself, and if we say that it converges to x, then there's nothing to prove because we already have that it converges to x. The proof is left as an exercise.